Hello everyone. Now the presentation is about efforts of visualization technology using information and communication technology. For introduction, Japan currently is facing the historical turning point due to lower population, fewer children and aging society. During this condition, to achieve the sustainable growth of the economy, it becomes a severe problem also in construction sites for rising productivity. From this background, Taisei Rotec becomes focused on the research development of using ICT technology for labor saving, visualization, and improving quality management. Here, about two technologies will be introduced. Number one is the research for road earthwork or subgrade compaction management, in which soil compaction can be measured by non-descriptive and area means. Number two is for visualizing underground objects by using HoloLens from Microsoft and BIM model, in which prevention of damage to underground objects and improvement of work efficiency can be possible. Now, it is about upgrading quality management and labor-saving technology by rolling type RI device. Currently, compaction management in the road earth and subgrade construction is performed as quality control defined in MLIGT, Ministry of Land, Infrastructure, Transport and Tourism. Generally, RI device or shunt replacement is used. In the test method, after compaction, the places are first determined and measured. Since the management is based on points, there may be concern of overlooking inadequate compaction places. Labor work is demanded to drill holes, so there needs at least one person as QC staff to do the test, and many lower postures required to do the work in the site, which are easy to be hidden in the blind spot of heavy machines. And so, serious accidents like collisions may occur. The next thing, after shunt replacement test is completed in site, moisture test is performed in the lab. It takes about 1 day to get the result for the short test. It probably needs to redo the work in case of unsatisfactory result. Here, time lag is found. To solve the problem, by incorporating three companies, Taisei Rotec, Taisei Kansetsu, and Soil and Rock Engineering are doing the research of DI compaction as the technology of upgrading quality management and labor saving in compaction in road or pavement construction. As shown in figure, rolling type RI device is built in the vibration roller. While running on the ground surface in contact, compaction rate can be measured automatically and non-destructively. And it is managed with location information from built-in GNSS. Rolling type RI device includes density and moisture meters of cylinder shape. The principle is the same as scatter type conventional device. Calculation is made for every 3.3 square meter and can measure with high density. Now about the applicability. MLIGT is implementing the project, named as a project related to the introduction and utilization of innovative technologies that dramatically improve the productivity of construction sites by using present budget. In this project, the technology proposed by our consortium, found with 5 companies, was adopted. Then, measurement of compaction rate in subgrade construction was performed by TI compaction. And from the result, the construction was attempted. The outlines are like that. The site was 2020 Midono North District PP pavement construction, ordered by Chubu Regional Development Bureau. Construction type is circuit construction M30. About 2,850 square meters was measured in 5 days. Then, for accuracy verification as well as necessary correction of rolling type aura intensity and moisture meter, field density tests were also carried out at 16 places by sand replacement method. Please watch the video of measurement. In TI compaction, the compaction rate can be measured while the vibration roller is running. The operator handling the measurement device. The density and moisture content can be measured with the rolling aura device. The recess can also be checked during operation. Then, the data being shared with cloud system and accessed from everywhere. The merits are like that. Compared to the conventional method, higher density of measurement is possible, and because of area measurement, overview of inadequate places is avoidable. Increased safety for not requiring any person to be inside. Cut labor saving because the operator of heavy machine can do the compaction measurement. By grasping the measurement recess in real time, actions can be taken as necessary and affects improving construction efficiency. Now it is about underground visualization technology by using HoloLens and BIM model. MLITD is promoting utility pole removal from the standpoint of farming good landscape and improving tourism, keeping safe and pleasant passages, reducing road disasters. According to the plan for promotion of utility pole removal formulated in 2021, the goal is to complete in all emergency transportation roads in urban areas where there is risk of electric pole collapse by 2050. In electric wire utility tunnel method, it requires to confine the ledger, which registers underground or buried objects, and do trial digging. There are some issues with this, such as 1. Time and labor requirement in trial digging. 2. Not always believable in underground object ledger. 3. Accidental damage to underground objects. From the above points, number 4, construction efficiency is not so good. The introduced technology uses HoloLens from Microsoft. By importing BIM model data in HoloLens and by matching marker displayed from HoloLens and the reference point of sight, the visualization of underground objects and pavement is obtained. The measurement accuracy depends on reference matching. The error may come out in centimeter unit in the smallest, but the person who wears HoloLens can see the site in real and 3D images of buried pipelines in combination, which means mixed reality MR. Next, about applicability at construction sites. Taking the advantage of electric wire utility tunnel construction in one national road, which requires not to damage underground objects like electric wires or communication lines, safe and accurate installation, we consider to use effectively 3D BIM model and ICT in this construction. The project is ordered by Kei Regional Development Bureau. The construction length is 7,185 meters, containing 7,110 meters of pipelines in total length. Practically, first, existing underground objects are acquired non-destructively. Then, 3D CAD model from the data and 3D design data are combined together to develop BIM model. With this visualization, design consideration can be done effectively. Next, in pre-surveying, underground objects are acquired by ground-penetrating radar, and point cloud data above the ground are found by terrestrial laser scanner, named Focus from Focus Company, as ground-penetrating radar (GPR). Hand-push type antenna radar is used, a skill card made from Geoscience Company, in which area data can be obtained. The performance of devices are as shown in tables and the condition of measurement as in the photos. The accuracy of hand-push type antenna radar is about 10 cm vertically or horizontally, but the accuracy can be improved by calibrating the position of known values like manhole and so on. And point cloud data above ground can be combined together to get more precise. The conventional drawings, like plans or sectional drawings, are complicated and require skill to confirm the pipeline location. But here, point cloud data and 3D pipeline models are used to develop same model with attribute information. Visualizing the data above ground, underground, and design in one 3D map makes clear to know the existing and new pipeline positions, and thus, before excavation starts, plan and revision can be checked well for pipeline interference from the design stage. As said earlier, pipeline interference can be checked on PC. In front-loading process, design can also be revised as necessary before construction. This helps for smooth concert with the client. In this construction, intelligent machine-controlled power shovel made from Komatsu Company is used. Since the location can be detected from GPS and many sensors to assist the operator, excavation can be done well along the surface respective to BIM model. Now to consider the construction efficiency. It took 48 days for BIM model development in this technology. But 46 pixels of interference, which were difficult to know with the conventional method, were confirmed in this method. So it prevented the reconstruction work. It will take 84 days for reconstruction with the conventional method. But by using BIM model, it took 0 days. As well as by using ICT with visualization, it saved 12 days. So 48 days were totally reduced. As the construction time of 220 days was reduced to 48 days with this technology, the construction rate is 22% up. Next, with HoloLens with MR visualization, the operator can aware the position of underground objects and conditions. Easily notice the buried objects in the excavation area and prevent damages to the objects. With the CIM model imported in ICT machine, over-excavation can be prevented. It relates to the prevention of damages to buried objects, and safety is also improved by reducing manual excavation or inspection. Finally, as future plan for ICT technology. Currently, Japan has problems with declining birth rate and aging population. So in future, by using ICT, it is aimed to contribute the society with innovative methods and sustainable development. Thank you for your attention.